All right. So let us proceed with the next part B. Part B, what are they saying? They want us to get the angle between SQ and QR. So this is S and this is Q. So we must draw a line from S to Q and QR. So there is a line here, SQ and QR. So normally the angle is between the common letter. The common letter which is there is Q. So the common point there is Q. So normally the angle is at that common point. We looked at this part A and we said that VR and QR. And we found out that the angle was at R. Why? Because R was common here at VR and also it was common here at QR. So R is common. So it means that the angle is at the common point, which is R. So even this one, part B, our angle is going to be at this common point, Q. So this is SQ and this is QR. So at Q, that's where we expect the angle to be between the line SQ and the line QR. So what we are going to do, we are going to go back to that diagram and we are going to draw a line QR. So something here. I mean SQ. So that is SQ. So we have SQ. That is SQ. And then QR. SQ and QR. So the angle is here. It's in between. Okay. So let us see if I'm going to draw a right angled triangle from that. So it means that I'm going to have here SR there. And I'm going to have SQ. Okay. So this is Q, this is R, and this is S. So which angle is between? Is at R here. When you look at this, the angle which is here is 90 degrees. So this is 8 centimeters and this one, if this is 4, if TW is 4, so it means that also SR is 4 centimeters because this side is equal to this side. So we shall have 4 centimeters. So they're asking us to find this angle which is here. For theta again, so this angle is what we have to find. So there we shall also use trigonometry and we shall say tan theta. Why do we use tan theta? Because we know this is the opposite and this is the adjacent. So we can use tan theta. So tan theta is equal to, let me ask someone. Tan theta is equal to Alexandria. Tan theta is equal to
4 over 8.
4 over 8. So theta equals to, and I know
over
you have
8.
already tested the calculator, so you are going to give me the answer. And theta is equal to
26.57.
26.6.
26.
26.6.
Is it okay? Any question? Can we go to the next question? We can see they had 36.9, which was our answer, and 26.6.
Teacher.
Yes.
Teacher.
Yes, Esther.
Teacher, you're too low.
I'm too low.
Yes.
Can you increase on the volume?
I've tried.
Teacher, it's general.
Okay, let me try and shout maybe and be very audible, but I'm seeing. I hope you hear me. Do you hear me?
Yes.
Not hearing me very well. Let me try to make things clear now. Do you get me now?
Yes.
Okay, very clear.
Yes.
So let us look at another example here, or another example. Check. So the next thing is we are talking about screw lines. But before we go to screw lines, let us do one more question here from the exercise here. That is finding the length. Okay, let us look at screw. They are called screw lines. Screw lines. The screw lines, they are saying that lines that are not parallel and do not meet are called screw lines. These are lines that are not parallel and these are lines which are parallel and they don't meet. So that this is a figure which is of a cuboid. This is a cuboid. So they're saying that from the figure, lines AH and EF, do you see EF? E and F. Do you see AH and EF? They are not parallel, but do not meet. So lines which are not parallel and do not meet are screw lines. When you look at EF, this EF, it is a horizontal line, and you look at AH, it is a vertical line. So these lines are not parallel. They are not parallel at all. This is horizontal and this is vertical. So they are not parallel. And two, these lines, they don't meet. They will never meet. This is this moving this side and this is this. So they are not meeting anywhere. They will not meet anywhere. So the name the name given to these two lines is what we call the screw lines. So we can give names of other lines on this figure. I can give you another one. For example, AB and what? And FC. This is vertical, this is horizontal. They don't meet. They don't meet and they are not parallel. Have you seen any other set of lines there? Members, are we together? When you look at AB is horizontal, and when you look at FC is vertical. So these two lines are not meeting. They are not, we can't say that point B is here where I see is. No, point B is this side, so they are not meeting anywhere. And they are not parallel. This is vertical, this is horizontal. So they are not parallel. Now there are other lines that we can see. Okay, Esther, do you have any other set of lines that you're seeing there?
Chad. HG.
HG and what? And HG and Look at any other vertical line that is not connected to this line. Is there any other vertical line that is not connected on this line? Esther, you have muted. Okay. Esther was saying HG. Is there any other person who can give us another line, another set, another corresponding set of HG that is not meeting? Esther?
Yes, teacher.
Yes. Okay, we have HG. Now, if you say HG and FC, that is correct. HG and FC, they don't meet. But if you say HG and DB, they are meeting at this point at D. So those ones are not screw lines because they are meeting. Though they are not parallel, but they are meeting. If you say HG and DB, those ones are not screw lines because they are meeting at D. But if you say HG and FD, they are not parallel and also they don't meet, and they also don't meet. Sherry is saying EF and, okay, HG and EF. Now, when you say HG and EF, they are parallel. So remember, screw lines are not parallel. They are not parallel. So HG and EF, they are parallel. That means that they are not screw lines. But if you say HG and ED, do you see ED?
Yes.
Yes, they are not parallel and they don't meet. So other lines like HG and D and HA, those ones meet, although they are not parallel, but they meet at H. You understand? HG and HA, for them, they are not screw lines because this HA meets at H at this point here. So they are not screw lines, but HG and DE, they are screw lines. So they are saying that to find the angle formed by screw lines, one of the lines must be translated. What do they mean by translated? We have to shift the line. So, for instance, they looked at AH and EF. AH and EF. So we have to shift either, we shift HA and we put it where E is. We shift H and we put it where E is, and A where D is, such that we have HA here where ED is. So that's what we call translating, such that we can get the angle between EF and HA. So to find the angle between screw lines, one of the lines must be translated, must be shifted. For example, from the figure above, the angle between FB, and EH, you can see FB and EH is found by translating line FB onto EA. Okay, let me try to draw that figure and then explain for you what they are meaning there. So here, screw lines, to find the angle between those two lines, we have to shift them. We have to shift them onto another line such that those two lines meet. That's what they are talking about. So the lines have to meet by shifting. I'm trying to be very accurate. I don't want things which are not accurate. Okay. So we have that. Let me see. Okay, we have that figure. So this is E, this is F, this is F, C, D, B, D, H, and A. I'm going to be a bit slow because I know this is a new topic to you, so, and you should do it at your name because it's one of the topics that you must be doing, that is the topics. Okay. Now they have said FB, so line FB, and line FB and line EH. These two lines are school lines. They are not parallel and do not meet. Not parallel, do not meet. You can see EH. EH is this one. This is the line EH. That line, it does not meet FB. This is FB. This dotted one is FB. So you can see this EH is this side. It is not connected to EF. There's to FB. There's no point that connects them. They are not connected anywhere. So it means that they do not meet. And also they are not parallel. You can see this is EHE. It's in that direction. And then BF is in that direction. So they are not parallel. They are not parallel. So they are also not parallel. So it means that these are skew lines. Skew lines. So to find the angle between them, they have said that the angle between FB and EH is found by translating. What does the word translating mean? Translating means we are going to move. Moving, we are going to move. We are going to shift. To move, we are going to move a line. So it is found by moving the line FB onto EA. So once we move this line and we put it there, we are going to shift it from this point here, and we shall move it there, such that this point becomes F, this one here becomes F, and this one becomes B. But why? Because we have shifted this line FB from here. We shift it from here, and we put it on EA. That's where we are going to put it. Now, once we put it there, it means that now the line HE will be having a common point with FB, because FB will be here. FB will be here. So let us try and shift that and we see. So I'm going to shift this. So I'm going to put F here, meaning I've shifted F there, and I'm going to put B here, meaning that I've shifted B there at that point. Now together. So that means that I have shifted F, we have shifted the F to that side, and we have shifted the B to that side. So after shifting this line to EA here, so it means that now we have FB. We are going to have FB and HE. Why do we shift this line here? So that the line HE and FB have a common point here. So at this point we shall be having F, not E. So this time we shall be having F because we have shifted the E here, and we have shifted the F here, and we have shifted the B there. Members, are we together?
Yes.
Yes. So now to find, so it means that now our new point is F, and here our new point is B. Put together. So now to find the angle between this H HE, which was here, and FB, this is the angle that they want, that angle. That's the angle that they want. And zoom in very well if you're not seeing clearly. That's the angle that they want, this angle here. So we know that at this point H, are we together? If you look at the triangle B, F, and H, B, F, and H, at this point here, we have 90 degrees. Look at this triangle here. So we know at the corners, we have 90 degrees at the corners. So here we have 90 degrees. We have 90 degrees. So we can extract out the right angled triangle from there and we draw it. So I will draw, let me just draw a right angled triangle. Let me draw the one that you normally know. Okay. But if I draw it like this, I must maintain those points. So where is 90 degrees? 90 degrees, if I may zoom in very well, 90 degrees is at H. So I must put H here. And I put 90 degrees. I put 90 degrees there. So what is this point? This point is F. And this point is B. So I have HB, this is the point, and I have this point here, the line HF, this is the line, and this is the hypotenuse. So where is the angle? The angle is at A, is at F. The angle is here at. So if I know HB, I can put it here. If I know HF, I can put it here and I find the angle C, the angle theta. Are we together, members? You unmute. I want you to, all of you unmute so that we talk to each other. Those ones who have funny background, you are the only ones who have to mute. But if you know your background is clear, you can unmute. So Patricia, are we together? Patricia, are we together? And Anua Sherry, are we together? Sherry, what's wrong with your microphone? Okay. All right. So they are saying that when this is done, when you move FB to EA, when this is done, point F coincides with E and B with A. So point F coincides with the point E. So point F is coinciding with point E. That's what we say. It coincides with the point E, because we move the F to point E. Are we together? And the point B coincides with A at this point. So F. So thus the angle between the two lines becomes this one, HEA. You can have HEA if you leave the E and A there, or you can have HFB if you.
Teacher.
Yes.
Teacher.
Yes, Patricia.
That means that you can also shift the right hand side.
Yes, you can also shift HE. Are you HE? Are you saying HE? You can also shift HE and you put it at GF. Are you saying such that our E is here, and the angle will be here. The most important thing is to have the angle between this line and this line. So we can shift this here, and we shall get the angle in between those two lines. Or we can shift this here, and we can get the angle between those two lines. Okay, thank you for that question. Okay, so let us look at one example about these screw lines.
Esther's putting up her hand.
Esther, I'm not seeing any hand here. Okay, Alexandria.
So why doesn't the B go down and the F go up?
Why doesn't the A go down?
No, why doesn't the B on the second diagram? Why doesn't the B go down and then the F up?
I beg your pardon. Why doesn't the
Why
A?
does the second diagram?
This diagram,
Why doesn't the B, the triangle?
This one,
No, the second one.
This one.
Yes.
Uh-huh.
Why doesn't the B go down and the F up?
Why doesn't the B? This B. Alexandra, try to be audible, try to be loud a bit.
I'm saying, okay, the right angle triangle that you've drawn. Why doesn't the B go down and the F up?
Why don't we put the F here and the B here? Is that what you're asking?
Yes.
Why don't we put F here and B there? There is no problem. You can put the F here. Someone can do it like this and say, let me have my F here and let me have my B here. But the H is there because H is at the right angle, isn't it? H is there. Now, this means that your angle theta will always be at F. Are you seeing that?
Yes.
So you can do it like that, no problem.
No.
Sorry? You can draw it like this as long as you maintain where the angle is. The angle is at F. So don't draw now the angle and you put it at B. The angle is at F. And what is HB? HB is B. So it remains the same. And if you want to find the tan of this angle here, we shall say tan of this angle theta for this diagram here. Tan theta is equal to be HB out of HF, isn't it? For this second triangle here, tan theta will be equal to, you can see tan theta will be equal to HB because this is the opposite side of the angle. So to be HB over the adjacent, which is HF. So in both, you get the same what? You get the same value.
Yes.
Are we together?
Yes.
Yes, because this side, you see this side is the one that is opposite to this angle, HB. So the opposite side is HB and the adjacent side is HF. But for this one, the opposite side is HB and the adjacent side is HF. So in both cases, we get the same answer. Okay. Any question? Members, if you want to ask, this is the opportunity that you have. You say, I'm very sorry because I want you to understand this to the, how do they call it? To the food, so that you get this into your head. And when you come back, you are an expert in 3 dimensions. Do you understand?
Mm-hmm.
Yeah?
Yes.
So we are left with 2 minutes. 2 minutes. Those 2 minutes, we can use them to work out this example, 10.3. So 10.3, they are saying that the figure below is a cuboid. The dimensions of the cuboid are 10 centimeters by 5 centimeters and 3 centimeters. Find the angle between CG and DE. CG and DE. So we are going to shift. Members, we are going to do what? We are going to shift. And we are going to translate. We are going to translate sides. So I want you to copy down that question there. And then we are left with just less than 50 seconds. So when we come back, we shall start. Sorry. A break of only 2 minutes will be enough. And some of you can even find out the answer of part A and part B in that break of 2 minutes. When you come, we shall be knowing the answer. Esther, are you saying something?